The actual generator, the thing that powers the craft that Lazar talked about, it was a discovery that stopped the world in its tracks. Voyager 2, humanity's oldest active spacecraft, suddenly went silent, vanishing into the dark void of interstellar space billions of miles away. For nearly 2 weeks, NASA searched desperately for any sign of life from the 46-year-old cosmic traveler. Then, on an ordinary day in August 2023, something extraordinary happened. A faint signal, a heartbeat, whispered back from the edge of the cosmos. What NASA uncovered next would stun the world and rewrite history forever. A cosmic whisper from the edge of forever. In the vast emptiness of space, 13 billion miles from Earth, a tiny spacecraft has been traveling alone for over 46 years. Built with technology older than most people watching this video, Voyager 2 silently carries humanity's message to the stars, a golden record filled with Earth's sounds, music and greetings in 55 languages. This cosmic time capsule, our message in a bottle cast into the cosmic ocean, suddenly went silent in July 2023. For nearly 2 weeks, this ancient explorer, humanity's farthest and oldest functioning spacecraft, vanished completely. NASA engineers stared at their screens in horror as the data stream that had been flowing continuously since 1977 abruptly stopped. Our interstellar ambassador was unreachable. No backup spacecraft existed nearby. No repair crew could be dispatched. No emergency protocol could physically reach it. Voyager 2 was truly alone, floating in a realm where no human voice has ever been heard. Then, after days of desperate scanning, something happened that stunned even NASA's most seasoned engineers. A faint signal, barely distinguishable from cosmic background noise, pulsed back from the darkness, like a heartbeat from the edge of forever. Voyager 2 was whispering back to Earth. The world collectively held its breath as NASA attempted the most ambitious long-distance rescue in human history. This wasn't just about saving a machine, it was about preserving humanity's voice in the cosmos. Our ambassador to the stars and one of our greatest achievements as a species, born in the golden age of space exploration. To understand why Voyager 2's near-death experience captured global attention, we need to travel back to the summer of 1977. Bell-bottom jeans were in fashion, Star Wars had just hit theaters, and NASA was preparing for a rare alignment of the outer planets that comes only once every 175 years, allowing a spacecraft to visit Jupiter, Saturn, Uranus, and Neptune in a single journey. Scientists called it the Grand Tour. On August 20, 1977, Voyager 2 lifted off from Cape Canaveral. Its twin Voyager 1 followed 16 days later. The original mission was meant to last just 4 years, a quick visit to Jupiter and Saturn. Nobody imagined these machines would still be working nearly 5 decades later, let alone become the first human-made objects to leave our solar system entirely. Each Voyager probe weighs about as much as a small car and carries less computing power than a modern pocket calculator. The main computer on board has just 69 kilobytes of memory, thousands of times less than even the cheapest smartphone today. Yet these machines were tasked with the most ambitious planetary exploration ever attempted. What made the Voyagers truly special was the famous golden records they carried. These 12-inch gold-plated copper discs contain 115 images of Earth, natural sounds, musical selections from different cultures, and greetings in dozens of languages, cosmic time capsules designed to tell the story of our world to any intelligence that might find them drifting between the stars thousands or millions of years from now. Both Voyagers traveled much farther than anyone dreamed possible. Voyager 2 became the only spacecraft ever to fly past all 4 outer planets, discovering active volcanoes on Jupiter's moon Io, revealing the complexity of Saturn's rings, and becoming the first to ever visit Uranus and Neptune. The moment everything went silent. Fast forward to July 21, 2023. After 46 years of nearly flawless operation, something went catastrophically wrong. NASA engineers at the Jet Propulsion Laboratory in California were sending routine commands to Voyager 2, standard antenna adjustments and basic housekeeping instructions that had been executed thousands of times before. But this time Voyager 2's high-gain antenna, the dish that beams signals back to Earth, shifted by just 2 degrees away from its perfect alignment with our planet. 2 degrees might sound tiny, about the width of your thumb held at arm's length, but across nearly 13 billion miles of space, that small misalignment meant disaster. Imagine trying to hit a target on the moon with a laser pointer and you'll understand the precision required. Communication dropped instantly. Voyager 2 went completely dark. The situation was beyond nightmarish for the mission team. There was no backup satellite nearby. No onboard camera to see what went wrong. No repair crew that could be dispatched. No emergency protocol that could physically reach it. It was alone in true interstellar space, floating in a realm where the sun is just another bright star. And now it was silent. Suzanne Dodd, Voyager's project manager, worried they might never hear from it again. The weight of that statement is staggering. Nearly 50 years of human achievement, representing one of our species' greatest engineering triumphs, was suddenly floating silent in the cosmic void. The timing couldn't have been worse. Voyager 2 had been sending back unprecedented data about interstellar space. Measurements of cosmic rays, plasma densities, and magnetic fields from a region no other probe has ever visited. Each transmission represented irreplaceable scientific knowledge from a place humans won't physically reach for centuries, if ever. And now, that stream of cosmic wisdom had gone silent. 11 days of cosmic silence. For 11 agonizing days, NASA's Deep Space Network, a global array of massive radio antennas in California, Spain, and Australia, scanned the heavens with desperate intensity. These giant dishes, some larger than a baseball field, are humanity's ears on the universe, designed to pick up the faintest signals from our most distant spacecraft. Engineers worked around the clock, adjusting frequencies, fine-tuning receivers, hoping against hope that somewhere in that vast electromagnetic ocean Voyager 2 was still calling home. The silence was deafening. Day after day, night after night, the radio telescopes picked up nothing but the background hiss of cosmic radiation. The challenge was immense. By 2023, Voyager 2's signal had become incredibly faint. Its transmitter puts out just 23 watts of power, about the same as a refrigerator light bulb. But that tiny signal has to travel nearly 13 billion miles to reach Earth. By the time it arrives, it's billions of times weaker than the power of a watch battery. Finding this signal is like trying to hear someone whispering in New York while you're standing in Los Angeles. And with Voyager's antenna misaligned by those crucial 2 degrees, the signal would be even fainter, perhaps too faint to detect at all. As the silence stretched from days into weeks, anxiety grew at NASA. Every passing day without contact increased the chances that the spacecraft had suffered a catastrophic failure. Maybe its ancient systems had finally succumbed to the intense radiation of interstellar space. Maybe its power had dropped below critical levels. Maybe, after 46 years of faithful service, Voyager 2 had finally reached the end of its remarkable journey. The thought of losing contact forever was heartbreaking to everyone who understood what Voyager represents. Not just a scientific instrument but a symbol of humanity's curiosity, ingenuity, and desire to reach beyond ourselves. Signals from nowhere. The first truly inexplicable anomalies in Voyager 1's data began appearing in late 2017. Engineers at NASA's Jet Propulsion Laboratory noticed that the spacecraft's Attitude Articulation and Control System, AACS, the system that keeps its antenna pointed at Earth, was sending back contradictory information. The telemetry data suggested the antenna was pointing in a direction that would make communication impossible, yet Voyager's signal remained clear and strong. It was like getting a phone call from someone claiming to be in Antarctica while your caller ID showed they were calling from next door. At first, engineers assumed this was just another glitch in Voyager's aging systems. The spacecraft was designed in the early 1970s and had been operating for 40 years in the harshest environment imaginable. Strange behavior was to be expected. They tried to diagnose the problem, sending commands for Voyager to run internal checks. But the anomaly persisted. And after months of analysis, they concluded something truly bizarre was happening. Voyager was somehow communicating correctly while simultaneously reporting its position incorrectly. It was as if the spacecraft was in 2 places at once. By 2023, even stranger anomalies began appearing in the data stream. Voyager's plasma wave instrument, designed to measure the density of the surrounding medium, started detecting rhythmic patterns unlike anything seen before. These weren't random fluctuations, but distinct oscillations with precise frequencies that showed mathematical relationships to each other. The patterns would appear for hours, then disappear for days, then return in slightly modified forms. It was as if Voyager was passing through structured regions of interstellar space, regions with properties unlike anything in our models. Some team members suggested these might be standing waves in the interstellar medium, similar to how a guitar string creates specific notes when plucked. Others proposed more exotic explanations, that Voyager might be detecting the boundaries between cells in the cosmic web, the vast network of filaments that connects galaxies. But none of these explanations fully accounted for the precision of the patterns or their persistence. Nothing in the interstellar medium should be able to create such structured signals lasting for months. Were these the first whispers of something we had never encountered before, something that existed in the vast darkness between stars, something that was now taking an interest in our tiny mechanical explorer? The The temperature mystery. In early 2024, the mystery surrounding Voyager 1 deepened considerably. The spacecraft's temperature sensors, instruments designed to monitor its systems during its planetary encounters decades earlier, began registering readings that defied explanation. These sensors had been essentially dormant for years, still connected but expected to show only the background cold of deep space, around 3 degrees above absolute zero. Instead, they began showing regular rhythmic spikes in temperature. Every 4.8 hours, the external sensor array would warm by nearly 30 degrees, then gradually cool back down. This cycle repeated with such precision that it could only be the result of external energy input. What made this truly extraordinary was that these temperature pulses corresponded exactly with the plasma wave oscillations detected months earlier. Whatever Voyager was encountering wasn't just affecting one instrument, it was interacting with multiple systems simultaneously. The NASA team ran exhaustive diagnostics, trying to find any internal explanation. Could residual heat from the radioisotope generator be cycling somehow? Was there a short circuit creating feedback between systems? Every internal explanation was ruled out one by one, leaving only the conclusion that Voyager was genuinely detecting something external, something with a regular, predictable energy cycle. The temperature spikes created another problem. They threatened Voyager's remaining operational life. The aging spacecraft was designed to operate in deep cold, and these regular heating cycles were stressing systems that had already far exceeded their planned lifespan. Engineers feared that vital components might fail as a result. Yet, strangely, despite these temperature stresses, Voyager's power consumption patterns actually improved. The spacecraft began operating more efficiently than its age and condition should allow. It was as if something was helping it compensate for the thermal stress, optimizing its energy use in ways its 1970s systems weren't programmed to do. This combination of threatening temperature spikes and improved energy efficiency baffled the NASA team. It was like watching an old car's engine overheat while simultaneously getting better gas mileage. The two effects seemed contradictory, unless some external force was both causing and compensating for the thermal stress. But the temperature anomalies were just the beginning. What happened next would challenge our understanding of physics itself. The final countdown. Power is running out. Despite everything we've accomplished, despite all the ingenious engineering solutions, Voyager 2 is slowly dying, and there's nothing anyone can do to stop it. Voyager 2 runs on a plutonium-powered radioisotope thermoelectric generator, essentially a nuclear battery that's been steadily decaying for nearly 50 years. Every single year, Voyager 2 loses approximately 4 watts of power as the plutonium fuel naturally decays. That might not sound like much, but when you're operating on the energy equivalent of a few dim light bulbs 12.9 billion miles from home, every single watt is precious. This power crisis has forced NASA into a series of devastating choices that nobody wanted to make. In October 2024, NASA made the difficult decision to shut down Voyager 2's plasma science instrument. This device had been measuring the solar wind during the planetary encounters and then transitioned to studying interstellar plasma. But after years of operation beyond the heliosphere, the instrument was no longer optimally pointed toward the interstellar plasma flow, and it was consuming precious power. Then in March 2025, NASA turned off the low-energy charged particle detector, an instrument that had been studying cosmic rays and energetic particles continuously since the Carter administration. This detector had provided invaluable data about the radiation environment throughout the outer solar system and into interstellar space, but the mathematics of power consumption had become unavoidable. After March 2025, Voyager 2 is operating with just 3 functioning experiments. Its magnetometer, which measures magnetic fields in interstellar space, its plasma wave antenna, which detects electromagnetic oscillations in the cosmic medium, and its cosmic ray telescope, which studies high-energy particles streaming through the galaxy. These final 3 instruments will continue operating on dwindling power, potentially extending the mission into the early 2030s, nearly 6 decades after launch. But even this timeline depends on perfect conditions. No major system failures and the continued ingenuity of NASA engineers, who have already performed miracles keeping this ancient spacecraft alive. By the early 2030s, the RTG will simply not generate sufficient electricity to power even the most basic systems. Voyager 2's transmitter will fall silent. Its computer will shut down. And for the first time since August 20, 1977, humanity will lose contact with our furthest messenger. Remote repairs. Engineering miracles from billions of miles away. What makes Voyager 2's survival story truly extraordinary is that NASA has essentially been performing surgery on a patient 12.9 billion miles away, using tools that take 19.5 hours to reach their target, with no possibility of real-time feedback or correction. Imagine trying to fix a complex piece of equipment when every command you send takes nearly 20 hours to arrive, every status update takes another 20 hours to return, and you have exactly one chance to get each repair attempt right. There are no do-overs when operating in interstellar space. In 2010, something terrifying happened that tested these remote repair capabilities to their limit. Voyager 2's data transmissions suddenly became completely garbled, streams of nonsensical data flowing back to Earth that no computer could interpret. For weeks, NASA engineers couldn't understand what their distant spacecraft was trying to tell them. The fear was that decades of cosmic radiation had finally caused catastrophic damage to Voyager's onboard computer systems. Then, after exhaustive analysis, they discovered the culprit. A single bit had flipped in Voyager 2's onboard computer memory. One tiny digital switch, probably corrupted by a high-energy cosmic ray after decades of exposure to the interstellar radiation environment. Ground controllers worked for days to develop the precise command sequence needed to remotely reset that single bit. They sent the commands across the void, waited nearly 2 days for confirmation, and successfully restored normal data flow. Think about the precision required for that repair. They diagnosed a single-bit error in computer memory, from 12 billion miles away, and fixed it remotely. But that's just one example of the extraordinary maintenance NASA has performed. When the spacecraft's main thrusters started showing signs of wear after 37 years of continuous use, NASA engineers activated backup thrusters that had been completely dormant since the 1980s. These backup systems, designed as emergency replacements, fired up perfectly after decades of inactivity, extending the mission by years and proving that 1970s engineering was built to last. NASA has even sent software patches across interstellar space, uploading new computer code to update Voyager 2 systems and compensate for aging hardware and gradual memory degradation. Every one of these repairs required months of planning, computer simulations, and careful testing to ensure that a single command error wouldn't end the mission permanently. The engineering teams have essentially become long-distance space mechanics, maintaining a spacecraft older than most of the people working on it. Our voice among the stars. Voyager's eternal legacy. So why did Voyager 2's recovery story make the whole world watch? Why did this relatively small technical rescue capture global headlines and trend across every social media platform? Because it represents something far deeper and more profound than just a successful engineering operation. Think about this for a moment. A 46-year-old spacecraft built with technology from the 1970s, before personal computers, before the internet, before cell phones, is still alive and functioning in the most hostile environment imaginable. That's not just impressive engineering. That's a testament to human vision, ingenuity, and perseverance that defies every reasonable expectation. It's proof that when we dare to dream big and engineer carefully, we can build things that outlast generations. But there's an emotional anchor to this story that made it resonate with people who normally don't follow space news. Voyager 2 carries the famous golden record, a phonograph disc containing Earth's sights and sounds, carefully selected to represent the diversity and beauty of human civilization. That record contains music from Beethoven and Chuck Berry, greetings in 55 different languages, the sounds of rain falling, babies crying, and people laughing, scientific diagrams explaining our solar system's location in the galaxy, even the brain-wave patterns of a woman thinking about love. These aren't just random signals drifting through space. They are our species' most carefully crafted whispers into the void, our message to anyone who might be listening among the stars. The golden record represents humanity's deepest hope, that we're not alone in the universe, and our profound desire to reach beyond ourselves and touch something infinite. When Voyager 2 went silent in July 2023, it felt like we were losing our voice in the cosmos. When that faint heartbeat returned from beyond the edge of our solar system, it was as if the universe itself was telling us that our message, our very essence as a species, was still out there, still traveling, still carrying our hopes and dreams toward distant stars. In about 40,000 years, Voyager 2 will pass within 1.7 light-years of Ross 248, a small red dwarf star. In approximately 296,000 years, it will pass within 4.3 light-years of Sirius, the brightest star in our night sky. And in roughly 2 million years, it will swing within 1 light-year of the obscure star TYC 3135-52-1. These cosmic flybys will happen long after our civilization has either gone extinct or evolved into something we can't imagine today, long after every human-made structure on Earth has crumbled to dust. Voyager 2 will still be out there, silently carrying our golden record through the galaxy. The global fascination with Voyager 2's recovery wasn't really about the technical rescue or even the scientific discovery. It was about something universally human, our need to reach beyond our limitations, to leave something meaningful in the vast darkness, and to know that our efforts to touch the infinite aren't in vain. As Voyager's power slowly fades and its transmitter eventually falls silent sometime in the 2030s, this remarkable spacecraft will transition from an active explorer to a silent messenger, carrying the golden record on a journey that will last for billions of years. Long after Earth itself has changed beyond recognition, the Voyagers will still be out there, tiny capsules of 1970s humanity adrift in the vast ocean of stars. That's a legacy worth celebrating, a dream worth protecting, and a story that reminds us all that the universe is still talking, and we're still listening. Thanks for watching another episode. While you are still here, make sure to click the video on your screen for more quality content.